In this example, we're going to balance a redox reaction. And first, we will balance it in acidic solution, and then we will balance it in basic solution after that. The redox reaction that we're going to balance is permanganate ion in aqueous solution plus iron 2 react, and the products are iron 3 in aqueous solution and manganese 2 in aqueous solution. And we're going to start by balancing this using the half reaction method in acidic solution. So the first step is to write half reactions for the species being oxidized and reduced. So in one of these half reactions, the ions are going to go together. And in the other one, the manganese and the permanganate are going to go together. Okay, so here are my two half reactions. I can do them in either order, it doesn't matter. So I'm going to start with the permanganate going to the manganese. The first step in balancing this half reaction is balance everything that is not hydrogen or oxygen. So there is one manganese on either side, so manganese is balanced. The next step is going to be balance oxygen by adding water. We have 4 oxygens on the left side and 0 oxygens on the right side. So we can add 4 waters on the product side, and that will balance the oxygen. Our next step is going to be balancing hydrogen by adding H+. If I look here, I have 8 hydrogens on the product side. I have 0 hydrogens on the reactant side. So I can use H+, and I will need 8 of them to balance the hydrogen. That's going to balance the hydrogen. The next step is going to be to balance the charge by adding electrons. If I look on the left side here, I have a -1 and a +8, so my total charge is going to be +7. On the right side, my charge is going to be +2. So if I want to balance that by adding electrons, I can add 5 electrons on the reactant side, and that will balance that charge by adding the electrons. So that's one balanced half reaction. Now, some of you might see that to balance the top one, all I really need to do is add an electron on the product side. And if you do, that's great, but I'll talk through the same 5 steps quickly. First, I'm going to balance everything. It's not hydrogen or oxygen. There's 1 iron on each side. Next, I'll balance oxygen by adding water, but there's already 0 oxygens on either side, so I do not have to add any water. I can balance hydrogen by adding H+. Hydrogen is balanced, 0 on either side, so I don't have to add any H+. So all that remains is to balance the charge by adding electrons. And if I add 1 electron on the product side, I now have a total of +2 on the left side and +2 on the right side. So there are my 2 balanced half reactions. The next step is, remember, in an overall redox reaction, the amount of electrons lost in the oxidation half reaction is going to be equal to the amount of electrons gained in the redox half reaction. So I need the same number of electrons on either side here. And so the easiest way to do that, since I have 5 electrons here and 1 here, is to just multiply this reaction through by 5. So I'm going to multiply this reaction through by 5, and then I would have 5 iron 2s goes to 5 iron 3s plus 5 electrons. And all that means is that for this overall reaction to be balanced, this iron half reaction, I'm going to have that occur 5 times, or 5 moles, for every 1 time that this reduction half reaction with the manganese occurs, because there is only 1 electron per iron, but each manganese needs 5 electrons. My next step then is to add together my 2 redox half reactions. So that means I'm going to be adding together the 2 that I have surrounded here by the lines, or in other words, the 2 half reactions that I have starred here. I'm going to add those 2 together. The second one, of course, not the one that I've starred here, excuse me, this one that I have starred here. Let's try that again. So I'm going to add the 2 that I've starred here together. Remembering the second one that I've starred is just this iron half reaction multiplied by 5 to get the electrons to cancel. So now I can add together these 2 redox reactions, and I can cancel anything it's going to cancel. So I have 5 electrons on the reactant side and 5 electrons on the product side that will cancel. That leaves, adding together everything in the left, I have a permanganate. I have 8 hydrogens, and I have 5 iron 2s. And on the product side, I have 5 iron 3s plus a manganese plus 4 waters. And this should be a balanced redox reaction. I can check to confirm that the atoms and charges are balanced. So I can look at this reaction, and I can start with manganese. I see 1 manganese on the reactant side and 1 manganese on the product side. So my manganese is balanced. For hydrogen, I see 8 hydrogens on the reactant side. I see 4 waters. 4 times 2 hydrogens in each water is 8. So I see 8 hydrogens on the product side. Hydrogen is balanced. If I look at oxygen, I see 4 oxygens on the left in the permanganate. I see 4 waters, each with 1 hydrogen on the right. So oxygen is balanced. And irons, I see 5 iron 2s and 5 iron 3s. So iron is also balanced. So now I just need to make sure the charges are balanced. I want to add up the total charge on the left. I have -1 for the permanganate plus 8 positive for the 8 hydrogens plus 10 for the 5 iron 2s. That gives me a total of positive 17 on the reactant side. If I look on the product side, I have 5 times 3 for the iron 3. That gives me a positive 15 plus 2 for the manganese is a positive 17 on the product side. So indeed, what I have here is a balanced overall redox reaction. Now I can say, so I'm just going to kind of erase here all of my checks for balancing, and what I have here is a balanced redox reaction. Now I can say that this is an acidic solution. And the reason I can say that it is in acidic solution is that I have these 8 hydrogens here. So that is a balanced redox reaction in acidic solution. Now, let's say that at the beginning I had wanted to balance it in basic solution. I can do that. The first step to balancing a reaction in basic solution is to balance it in acidic solution. So to balance it in basic, you would go through all of the steps that I just did. And now we're going to move on to balancing it in basic solution. Okay, we're going to move on at this point to balancing it in basic solution. So to start that, the first thing I'm going to do is I'm going to add hydroxide to each side. So I'm going to rewrite this reaction. I'm going to rewrite this reaction, but I'm going to add, and then once I do that, to get it to basic solution, I'm going to add hydroxide to each side. And the hydroxide that I'm going to add is going to be enough to neutralize any hydrogen. So if I add 8 hydroxides, and again, I have a balanced redox reaction in acidic solution right here. So if I add the same amount of hydroxide to both sides, it will stay balanced. So here I've added 8 hydroxides to either side, so the reactions should still be balanced. But now, this hydrogen and hydroxide is going to neutralize each other to give me 8 waters. So now I have a permanganate still, plus 8 waters, plus 5 iron 2s. And I'm just rewriting the rest. Gives me 5 iron 3s, plus a manganese 2, plus 4 waters, plus now I have 8 hydroxides on the product side. Now we can see that I can cancel some waters. I have 8 waters on this side and 4 waters on this side. So I can remove 4 waters from each side. And then I can rewrite it having done that. And my overall balanced reaction is now going to be permanganate ion plus 4 waters plus 5 iron 2s, and that's going to yield 5 iron 3s plus manganese 2 plus 8 hydroxides. And that is my overall balanced redox reaction in basic solution. Again, I can check there is 1 manganese on each side. There are 4 oxygens in the permanganate plus 4 more in the waters for a total of 8 oxygens on the left. There are also 8 oxygens on the right. If I balance hydrogen, there are 8 hydrogens on the left with the 4 waters. There are 8 hydrogens on the right. Finally, I can check to make sure that I have balanced charges. If I look at my total charge on the reactant side, I have -1 plus 10 gives me a positive 9. And on the right side, I have 15 from the 5 irons plus 2 from the manganese is 17, minus 8 from the hydroxides is positive 9. So here I have a balanced redox reaction in basic solution. How can I tell that it is in basic solution? I can tell that it is in basic solution due to the presence of the hydroxides here. So that concludes balancing these reactions in acidic and basic solution.